Hello everyone, I'm Ankita. My project partner is Anusha. We are going to present our EE278 turn project. Our project is FPGA based image warping using affine transform. We completed this project under the guidance of Professor Chang Chu. We'd like to thank Professor Chang Chu for giving us the opportunity to work hands-on with the Altera FPGA tools. Let's get started. The first thing we do is write an algorithm in MATLAB. Here we created a checkerboard in MATLAB and we are storing this checkerboard pixels in an array. Next, we generated an affine transform matrix by giving a scaling factor of 0.6, an angle rotation of 40 degrees, and we have also shifted the x and y axis by 2 units. After this, we have warped the incoming corners to determine what would be the output image size. After this, we are performing the inverse transform using backward mapping method. And finally, we are resampling the image using bilinear interpolation. We have implemented this algorithm in MATLAB and we have got the following outputs. This is the input image, this is the warped checkerboard, and this is the reconstructed checkerboard. As you can see, the warped image is rotated and it is also scaled to a smaller size. You can also see that it is shifted from the axis. Now we have to implement this in Quartus. So let's go to Quartus. The first thing to do in Quartus is to create a new project. Here I will select my working directory. I will give a name to the project. There are no files to include. The Altera DE1 board that I am using belongs to the Cyclone 2 family and it has a pin count of 484 and a speed grade 7. So select this. The format is Verilog HDL and it would be simulated using ModelSim Altera. A new project is created, so now we invoke the QSys tool. In the QSys tool, I will create a new component for my hardware accelerator. Here I will extract the files of my hardware accelerator. Our hardware accelerator does the matrix multiplication. There are no errors, so these are the signals that it extracted from the hardware accelerator, and the interfaces, the right connections have to be given to the clock and the reset. Say finish, save it. Now we have to generate all the HDL files. Now we have to create different modules. So let's start with News2. We will be using the News2 economic version, the on-chip memory. I'm using 8192 bytes of on-chip memory. Next, the JTAG UART. The performance counter. And finally, the hardware accelerator that we created. Now we have to give the proper connections. So let's start with the clock. Then the reset. The instruction master will be assigned only to the on-chip memory since it fetches all the instructions only from the on-chip memory. The data master, however, is given to all the modules. Clock and reset is connected. Let's connect the interrupt pin. You can see that there are a lot of errors generated. In order to remove these errors, we have to assign the base address. Now we have to assign the vector memory to the on-chip memory. Now we have to generate our HDL files. So let's generate them. We have to save the file. Keep in mind that you have to save it with the same name that you have given while creating the project. Now we have to import these generated files in quarters. So let's add the files. We have to import the .qip file, which consists of all the Verilog information. Say add. Now we have to assign the pins. We will be assigning pins only to the clock, since the rest of the pins are inbuilt. Choose IO standard. Save this and compile it. By the time it compiles, let's look at the C code. This is the corresponding C code for the image warping. Initially, we given the pixel values of the checkerboard. After this, we generate a transformation matrix using the sine and cos values. After that, we are warping the incoming corners so that we can find the image size of the output image. Then the backward transform is performed using matrix inversion. And finally, the bilinear interpolation is done for resampling. Let's see if it is compiled. Compilation is successful, so now let's program the FPGA board. Here you have to select the .sof file, and now we will program it. The FPGA board is programmed successfully. Save it. Now we have to build the Neo2 system in Eclipse. Here I'll be choosing my working directory. I will be using the Neo2 BSP template. Here we have to import the SOPC info file from the working directory. Give a name to the project. I'm using the default location and selecting the Hello World small template. This is how the hello world small.c looks like. Now to check whether the board is working fine, let's build the project and run it. The project is built, so now let's run it. The board has returned the hello from Neos2, which means all the connections are fine. Now we have to replace this hello world template with our C algorithm. So let's go to our C code, select it and paste it. Let's save it and run it. We can see that the system has consumed these many cycles, and these are the output warped image pixel values. So this is the warped image. Thank you.